Okay, so having talked about units, talked about the fact that we want to work with stuff within the SI unit system, we know that we're going to have to deal with things that are in different units. So whether that's in different metric units or in English units, that we're going to need to get into metric units. So the question becomes, well, how do we deal with stuff that has different units? And there's a couple things to sort of lay out right up front. The first thing is, if you want to talk about someone's height, so say my height, and I told you that my height was 5 feet, that's a length, plus 10 seconds, you would recognize that that makes no sense whatsoever. What does make sense is if I tell you that, oh, my height is 5 feet, that's a length, plus 10 inches, that's also a length. So part of what these two examples tell us is, one, I cannot add together quantities with different dimensions. Length and time are two different dimensions, and so adding them or subtracting them doesn't make any sense. Right? So length plus time, length minus time, none of that means anything. That's just silliness. I can, however, add together quantities that have the same dimension but different units. But it can be very dangerous when I start doing calculations. So one of the things that we just want to be very good at is converting everything into a single unit. So I'm sure you guys have done unit conversion in other science classes before. If you're very comfortable with doing unit conversions, great. If you've got a technique that already works for you, great, use it. I'm going to walk you through sort of the how I do unit conversions, and for those of you who aren't quite as comfortable as what you should be, this is what you want to do. So we're going to practice unit conversions because that's a skill that we're just going to need to use a lot, and we want to be very good at it. So what's the process then in converting from one unit to another? And the key is remembering that units combine algebraically. So let's take that height again. So my height, 5 feet plus 10 inches. If I want to convert this into either telling you my height completely in feet or telling you my height completely in inches, then the thing I've got to have is I've got to have some relationship that tells me how many inches there are in a foot. That's called an equivalence relation. So basically it's the equation that tells me 1 foot equals 12 inches. Now, I could also use the equivalence relation that 1 inch is equal to 1/12 of a foot. That's also an equivalence relationship that I could use, but we tend to write these from the one of the larger thing equals so many of the smaller things. Either way, it doesn't matter, as long as I have an equivalence relation. So what am I going to do with this equivalence relation? Well, there are two ways that I can sort of make this work for me, and largely it just depends on what I want to end up with my final height then. Do I want it in feet or do I want it in inches? But notice that either of these two ways, basically what I'm doing is I'm going to take my equivalence relation, and so what have I done over here? Well, I took 1 foot and then divided both sides by 1 foot. So 1 foot divided by 1 foot gives me 1 equals 12 inches divided by 1 foot. So that means this is really just a fancy way of saying the number 1. Over here what I've done is I've taken and divided both sides by 12 inches. So 12 inches divided by 12 inches, again, that's just the number 1. So this is 1 foot over 12 inches. This is another way of just saying the number 1. And the reason that's useful is that I can always multiply any number by the number 1 and not change it. So if what I wanted to do was tell you my height in inches, then basically I need to convert from feet to inches. And so I'm going to take my 5 feet, my quantity 5 feet, and I'm going to multiply it by the right version of the number 1, so it's still the same, but now it's going to be in inches as a unit. Notice what's going on here algebraically. Why did I pick this one rather than that one? Here's feet in the top of my fraction. Here I'm dividing by feet, which means those two things are going to cancel. The feet cancel out. I'm left with inches. So my height ends up being 5 times 12 inches divided by 1. That's another way of saying 60. So my height is 60 inches plus 10 inches. That's 70 inches. So 70 inches is equal to 5 feet 10 inches. Or, if the other option I wanted was to tell you my height in feet. Well, so now what I need to do is I need to convert 10 inches into feet. And so that means since inches is on top here, I need to divide by inches on here. I need it to be on the bottom. So again, if I multiply by this particular fraction, where feet's on top, inches is on bottom, then the inches will cancel, and I'll be left with a quantity that just has units of feet. So I'll have 5 feet plus 10 times 1 divided by 12. So in decimal form, that's just 0.83 feet. So my height is 5.83 feet. So all of these, 5 feet 10 inches, 70 inches, 5.83 feet, all of these are exactly the same. All we're doing is changing the units. And so this process of figuring out using our equivalence relation and figuring out what fraction I need to multiply by, we're just going to use our units and think about how they cancel out algebraically to help us, to help make sure that we end up with the right fraction. So let's say one more example. So let's say I wanted to convert from, MPH is a fancy way of saying miles per hour, into meters per second. So it's a little bit confusing because we're using the same m here. So let's just sort of clean that up. So we're going to say I've got a speed that's equal to 60 miles per hour, and I want to convert that into units of meters per second. So what I need then is I need two equivalency relations, one for what's going on with length, one for what's going on with time. It happens that I do know an equivalency relation that connects miles and meters. So I know that 1 mile is 16.09 meters. In terms of time, well, I know that there happen to be 60 seconds in a minute and 60 minutes in an hour. So I can go from seconds to minutes, minutes to hours. So I've got two equivalency relations that'll take care of what I need to do in terms of time. So here are the three equivalency relations that I need to do this unit conversion. So again, I'm going to start with my values, 60 miles per hour. And in this case, I know I've got miles on top, which means I need miles on bottom, so that those two things will cancel. So the 1 mile goes down here. The meters is left to go on top, so I'm just putting the numbers with the units. And then I can do the same thing with time. So now when I go to think about time, well, I've got hours on bottom, which means it needs to cancel out with hours on top. If the hours goes on top, then the minutes has got to go on the bottom. That way those two things can cancel. And so now I just come back and put in the numbers. 1 goes with the hours, 60 goes with the minutes. So here I've got miles has canceled, and I've been left with meters. Hours has canceled, and I've been left with minutes, so I need to go one more step to get into seconds. And so that's where I'm going to now multiply so that my minutes on bottom, I'm going to multiply with the fraction where I put minutes on top. That way those cancel out. And again, what I'm left with is the seconds went on bottom. And so you notice if you just look at the units here, everything is canceled on top except for meters. That's what I wanted, was just meters on top. Everything is canceled on bottom except for seconds. Again, that's what I wanted, just seconds on bottom. So I've set this up, and it's just sort of thinking about my units algebraically is telling me that I've set this up correctly to end up with my same speed in units of meters per second. And so now I just need to do the math. So everything on top in the fraction gets multiplied together, so that's 60 times 1609 times 1 times 1. There's that line. All of it's got units of meters because that's what's left on top in terms of units. On the bottom, well, this is really 60 over 1, so that's 1. There's 1 times 60 times 60. So 1 times 60 times 60, and again, the units I've got left is seconds. So I end up with 26.8 meters per second. So this is the process that we want to get really, really comfortable with. We'll work with it in class on Tuesday. And so hopefully this is something that won't take you long, because again, you'll already be very comfortable with this, and so we can go through it relatively quickly.